What's up, Algebra 2 students? Let's do the homework here. We are simplifying square roots. We might be doing it a little bit differently from what you've done in the past. You might have seen factor trees in the past, but we're going to try to keep it a little bit simpler than that. Our goal is to simplify the square root. Why do we simplify square roots? It's because it's the way to add some square roots together. Back in the day, before they had calculators, they needed to be able to figure out the exact value of like the square root of 108. It's actually helpful to simplify it first. So that's why we're doing it. It's like a standard form for answers. We're doing it. And how are we going to do it? Guys, well, we're going to focus on, and we're going to use our calculator a lot. We're going to focus on what are perfect squares and what are square roots. Square roots is like a button that tells you, it's a function that tells you what is the number times itself to give us this number. Like the square root of 9, let's all find the square root button right here, second over x squared, no matter what calculator you're using, that's typically right. The square root of 9 is 3. That's just telling you 3 squared is 9. Okay? Now, if I type in the square root of 108, I realize, okay, square root of 108 is a crazy decimal. We don't want like that. We would like to try to like simplify it, make it look nicer so we have like an amount of like simpler square roots. So here's what we're going to do. It's very simple. You are going to start by dividing 108, our number right here. We're going to divide 108 by all of these perfect squares. So start by dividing it by like 81, then 64, then 49, then 36. We do that to see like what is the largest perfect square that goes into 108. So I'm going to do 108, and I'm going to start dividing by our big perfect squares. We're going to go biggest to smallest, okay, largest to smallest. 64 doesn't work. 36 works, okay? Now, 108 divided by 36 is 3. Now, what does that mean? That means like 108 is 36 times 3. Now, it's root 108, so we're going to write root 36 times root 3. Now, again, like, what are we doing? We are going to simplify the square root of 108. Well, we realize that the square root of 36, and this is how we're checking to see our answers are correct, times the square root of 3 is that same number. But what do we know? The square root of 36 is just 6. The square root of 36 is just 6. So I'm going to change the square root of 36 into just 6. And I see 6 root 3's is the same as the square root of 108. Let's see, 6 square root 3. I should get 10.3923. Okay? This is something that can be manipulated easily. We can add it to other square roots that are root 3's. We can, if we didn't have a calculator, figure out what 1.7 was using a table and then multiply by that by 6. Like these are all the reasons why we simplify. Okay? So that's all we're doing. We're taking the number. We're going to divide, using our calculator, this number by big perfect squares. We're going to start with the biggest one that we can. What's the biggest one? 98, I'm going to say 64. Now, I know it's not going to be 64 because 64 times 2 is going to be bigger. So I'm going to try other ones like 49. 49 times 2 is 98. So I'm going to write this as 49 times 2, but it's not that. It's the square root of 98. So it's the square root of 49 times the square root of 2. Why do I put that? Because the square root of 49 is just 7. The square root of 49 is just 7. It's not root 7. The root goes away. I just took the square root of 49. It's 7. And I get 7 root 2. I'm going to double check. The square root of 98 is the same as the square root, is the same as 7 times the square root of 2. Correct. We are done. We just simplified. Okay, let's keep going. 28 divided by 16. Nope. 28 divided by 9. These are like the biggest perfect squares that I think can go into 28. 28 divided by 4, 7. Root 28 is root 4 root 7. Root 4 is 2. 2 root 7. Double check, did I do this correct? Square root of 28. Simplified is 2 square root 7. Root 45. Okay, start dividing 45 by perfect squares. Start with the biggest that you think. 25 doesn't work. 16 doesn't work. 9 works. 9 times 5 is 45. So root 45 is root 9, root 5. The square root of 9 is 3. The square root of 9 is just 3. So we get 3 root 5. 112. I'm going to start with 64. 64 times 2 I know is 128. So I know that's not going to be right, but like start there. 49. 36. 25. 16. Boom. 16 times 7 is 112. Root 112 is root 16, root 7. The square root of 16 is 4. 4 squared is 16, so the square root of 16 is 4. We will be using square roots a lot this unit to solve quadratic equations. So we're going to be dealing with roots of numbers a lot. 75. Start with 36. Doesn't work. Start with 25. 25 times 3. Root 25, root 3. 25 is 5. 5 root 3. Don't turn root 25 into root 5. That's not right. The square root of 25 is just 5. The square root of 25 is just 5. I'm going to double check. I didn't do that for the last one. The square root of 75 should be the same as 5 times the square root of 3. I haven't changed it. I just made it look different. This is a great way to check all your answers, is to plug in your first one, plug in what you think is the simplified one. It needs to be the same. Roots work like exponents. It is an exponent. It's actually a 1/2 power. If you were to like take an exponent like of a fraction, you actually find that you could just take the top to the exponent and the bottom to the exponent. Now, maybe that doesn't make sense to you, but like what I'm trying to tell you is that if you're taking the square root of a fraction, you could take the square root of the top and the square root of the bottom separately, and then just divide the two numbers. Now, what's the square root of 9? Oh, it's 3. Use your calculator to double check. What's the square root of 16? Oh, it's just 4. Use your calculator to check, right? 3 squared is 9, so the square root of 9 is 3. 4 squared is 16, so the square root of 16 is 4. I get 3/4. Okay. Root 164. Well, 1 over 64. Well, it's the same as the square root of 1 over the square root of 64. We're okay with this. We're not going to freak out about fractions. Just take the square root of the top and the square root of the bottom. The square root of 64 is 8. Now, sometimes you'll have numbers in front of roots, multiples of these roots. Well, just work your way down and just make sure everything like stays there and doesn't disappear on you. I find a lot of my students like to try to skip steps. Please don't try to skip steps. Just like write down what the square root of 4 is. Oh, the square root of 4. Oh, that's one of those perfect squares. The square root of 4 is 2. So the square root of 4 is 2. Now you realize it's 5 times the square root of 4. That's just 5 times 2. That's just 10. This is the same. And honestly, if you just typed in 5 root 4, you would have gotten 10 in your calculator. Same here. But what we're leading you to is the fact like sometimes you won't be able to simplify. The square root of 63 is not a perfect square. 64 is a perfect square. So what we're going to do is kind of what we've done is we're going to use our calculator and see what is the biggest perfect square that goes into 63, into 20, into all of these other ones, and then we'll be able to simplify from there. Okay, so I'm going to try to divide 63 by 49. I don't know why I typed in 60. I know that's not going to work. I'm going to try 36. Doesn't work. I'm going to try 25. I know that's not going to work. I'm still trying biggest to smallest, biggest to smallest. 16. Doesn't work. 9 works. The 7 keeps throwing up. Okay, now let's be careful. That 3 stays. 63 is 9 times 7, but again, it's root 63, so it's root 9, root 7. The square root of 9 is just 3. The square root of 9 is just 3. The square root of 7 is ugly. You can't, and I haven't been showing you this, but you can't simplify the square root of any of these other numbers. Besides these perfect numbers, all of the other square roots that we've had, 7, 3, we had 3 here, 2, 3, we've had that a couple times. You can't simplify that to be a nice number, so you just leave it. It is like an ugly square root. It's an ugly decimal. We're just going to leave it because you can't simplify it. You can't divide any of these numbers by it. You can't divide 7 by 4. So you're just going to leave some square roots in your answers, and that's okay. We're simplifying it so we have like an amount, a whole number amount of the smallest possible root. All right, sorry. That was a tangent. Now we go into like, what is this? Well, 3 times 3, I can do 3 times 3. But I can't do 3 times root 7. It's ugly. You want to multiply that by 3? Yeah, it doesn't work out. It's ugly. You can't do 9 root 7. That's ugly. So you just leave it as 9 root 7, but you realize that 9 root 7 is the same as 6 root 63. Okay? 20. Simplify 20. 9. Nope. 4. Yep. 4 times 5 is 20. 4 times 5 is 20. So 4 times 5, but it's root 20, root 4, root 5. 6 states. Root 4 is 2. Root 5 is root 5. Root 5 cannot be simplified. Root 5 is an ugly decimal. It's the smallest root that's left over that's perfect. Don't multiply 2 by root 5. That's not root 10. Okay? 2 root 5 is just an ugly number. But multiply 6 by 2 to get 12. $128. 81. 64. Bam. 64, root 64 times root 2. We're always going to start with this number, this perfect square. That comes first. Root 64 times root 2 is root 128. The square root of 64 is 8. The square root of 64 is 8. So 3 times 8 times root 2. 3 times 8 is 24. 24 root 2. 117. Fun. Let's try 81. 64. 49. 36. Nope. 25. Nope. 16. Let's try 9. Ooh, 9 and 13. That's fun. So 5. 9 times 13 is 117. Root 9 times root 13 is root 117. Root 9 is just 3. Root 13 cannot be simplified. You can't divide it by 16, 9, or 4, so it's the smallest root that is left. You can't multiply 3 by that. You can't multiply 5 by that, but you can multiply 5 and 3 together. 5 times 3 is 15. You can double check. 5 square root 117. is the same as 15 square root 13. There you go. All right, last thing is we are going to take the square root of this seemingly complex thing, this b squared minus 4ac. You actually have seen this before in Algebra 1. Okay, this is part of the quadratic formula, which is a formula used to solve quadratic equations using square roots. Okay, quadratic equations has x squared. We can use square roots to solve these. This is where the square root kind of shows up with the quadratic formula. Now, all we're practicing here is plugging in a, b, and c into the square root part and just evaluating it and simplifying it. What we have to know is that you are not allowed to say I have subtraction, like square root of 25 minus 16. You're not allowed to separate this and take the square root of 25 and then subtract the square root of 16. This is wrong. You might think, oh, but this is what I've been doing. I've been kind of like distributing the square root. That doesn't work over addition and subtraction. What you actually have here is a situation where this is in a big set of parentheses. So, if you're thinking about PEMDAS, parentheses need to come first. The exponents are going to come second. Square root is an exponent. The parentheses with the subtraction, that's going to be first. Okay? So here's what we're going to do. We are going to figure out what this b squared minus 4ac is. I'm just going to kind of put that on the side. It's actually called a fancy word. It's called a discriminant. Discriminant is like the number that comes inside your square root. And all we need to remember, and this goes back to Unit 1, is that when you're substituting, use parentheses, like A, B, C. Make sure, and do it with your calculator, you plug in parentheses when you are substituting. It's not necessary, but like you're safe here. This is b squared minus 4ac. Your calculator takes care of order of operations as well, though it's like set up to be in order of operations where you're squaring first, then you're subtracting the multiplication. Potentially, I'll show you something in a second, but we get 25 here. Now, potentially, guys, if you're in this mode, I want to see if this if you're in like a classic mode or if you have an older calculator, I want to see if we get 25 here. So b squared minus 4 times a times c. I'm hoping that we still have order of operations in our calculator here. Okay, we're good. We're safe. Never mind. So we don't have to worry about it. I was thinking like sometimes older calculators, they're going to subtract the 4 and then multiply by A, then multiply by C. They go things like one at a time. Newer calculators understand order of operations and follow. Okay, so that's just this b squared minus 4ac part. That means we're taking the square root of 25. So we found b squared minus 4ac is 25. Now we're going to take the square root of 25. Well, I mean, plug it in. If you get, oh yeah, the square root of 25 is just 5. 5 squared is 25. Square root of 25 is 5. Boom, we're done. This is our answer for right now, is that we get 5. Okay, we're going to do something with that 5 in the future. 1, 8, and 9. So let's figure out what b squared minus 4ac is using our calculator, using parentheses, because we're going to make b negative, and I'm going to show you what happens. I get 28. Okay, so that means I have the square root of 28. Now, what's the square root of 28? Oh, it's an ugly number. Oh, we need to simplify it. This is where we start dividing it by our perfect squares. Can 28 be divided by, don't look at 2, 3, 4, 5, 6, 7, 8. Look at 4, 9, 16, like the square root numbers. 28. 28 is a square root. Let's simplify that using square roots. Can we divide it by 16? Nope. Can we divide it by 9? Nope. Can we divide it by 4? Yes. Root 4. 4 times 7 is 28. But this is the square root of 28, so this is the square root of 4 and the square root of 7. The square root of 4 is 2. 2 root 7. 2 root 7 is the same as root 28. Root 28 we did earlier. 2 root 7. Boom. All right, be careful when b is negative. Here's the mistake that is made. When people don't use parentheses and they say, hey, square negative 3, your calculator gives you negative 9. This is correct. Your calculator is using order of operations to square the 3 first and then multiply by a negative 1. But we know better. We know that negative 3 times negative 3 is positive 9. We know better than to substitute without using square roots, to substitute without using parentheses. Sorry, I was talking about square roots all day. So we need to make sure we have b squared, positive 9, okay? B squared minus 4ac. Use parentheses, you'll be safe, you'll get the correct value underneath this, the square root. B squared, you do this in multiple steps, just get the right answer, minus 4 times a times c, boom, 49 is the number. So that's the square root of 49 is what we're trying to figure out. Oh, the square root of 49 is just 7. Or you plug that into your calculator, you just get 7. Okay? And the last one, b squared minus 4 times a times c. B squared minus 4 times a times c. And that's 88. Okay, 88. So I want to take the square root of 88. That's not a nice number. That's not a perfect square. So we are going to try to simplify that. What is the biggest perfect square that goes into 88? Well, start dividing. 36. Should have tried 49, but we know that's not going to work. 25. 16. No. 9. Nope. 4. Yep. You might not think it, but 4 is the biggest perfect square. 22 is the smallest root that can come out of 88. Root 88 is 4 times 22, but it's root 88, so it's root 4, root 22. The square root of 4 is just 2. 2 times root 22. That's it. Okay? That's your homework. Hope we understand things. Hope we are not intimidated. As long as you have your calculator, you're good to go. Thank you very much. I will stop recording.